Hi, I'm excited to be here at the Data Platform Virtual Summit. I'm going to be presenting on developer productivity engineering, which is the next big thing in software development. My name is Amanda Martin, and I'm the developer advocate for Gradle Build Tool. And I just want to say that this is such a cool platform because even though I'm here talking to you what seems like live, I'm actually in the chat too, answering your questions. And so as I'm talking away, feel free to ask, why'd you say that? Why'd you say that? And that's because this is all pre-recorded. So it's really cool that the Data Platform Virtual Summit is offering it in this manner. Okay, so let's get started on the developer productivity engineering. So people often ask, why did you start software development? Well, this is kind of why I started. The first time I was on a computer, it was such an exciting prospect. You do something and then bam, you see something change. And I've done a lot of teaching over the last, 20 years or so, and this is something that I see again and again. Students, they come to the computer and, if it's in processing JS, then they can like tweak a little box and then magically, their snowman turns a color or their ball is bouncing or they're doing something that is just so awesome and they see that they did that. And so this means that they get excitement by changing little things. This is the feedback cycle. And the shorter the feedback cycle, the happier you're going to be whenever you're starting to do your coding. So, when was the first time that you wrote code? And what was the feeling that you had when you wrote that first line of code or did that first data platform procedure? Did you have to wait a long time to see the results? Would you still be where you are today if it took a long time for that one line of change to actually do something? My guess is probably not, but I would really love to hear your first experience with coding and why you love computers. Because the fact is that we start in a certain spot with computers where it's all excitement and fun. And then over time, we get bogged down with all of the nitty gritty details, and our problems become harder and harder. But the reality is that, in general, development is a creative process. Whenever we're writing code, we're using both sides of our mind. Um, you can think of this as coding or data processing is similar in creativity to an experimental scientist. Scientists have to hypothesize and then enter a dialogue with nature via experiments on whether that hypothesis is correct. Our hypothesis is our code, and the dialogue is with the compiler, the unit integration and performance test, other validations, and interacting directly with the running software. So our creativity requires a dialogue. The quality of the creative flow for your developer demands how functional that dialogue is in an ideal world. You get answers instantaneously, and the answers are always correct, and your changes are always immediately available right at runtime. This means you send your hypothesis and you get answers back right away. There is no waiting around, and that allows you to have that fully creative process go full cycle. Another thing that we've learned is that the best code is written by happy developers. So we should strive to foster a sense of developer joy because software innovations are augmenting global innovation and solving the biggest challenges. This is one of the reasons why I decided to get back into coding. I started coding because it was just amazing and I loved it, but then I got bogged down in all the details, so I stopped for a while and went to teaching. But then I saw how much that code is changing the lives of everyone. I'm a big believer that coding, specifically open source, is going to enable us to solve all of the problems and make it so that we can live in this world and make it go from the image that you see over on the left through science to the image that you see on the right. Now, this is going to be something that has to be adopted at a large scale, which is why I am here presenting to you, because I think by having this developer project of engineering, we can create this sense of joy for all of your developers. And as they move forward, they are going to be solving more problems. Okay. But instead, we generally have software development that has made this unique set of frustrations, right? Um, Oftentimes, a software person's calendar might look something like this, where they have dedicated coding time, where they go and they start their pull request or whatnot. And then, they have about 15 minutes where they wait for the local build. It failed. They debug the failure. Why did it fail? I have no idea. I spent all of that time coding and then it failed. Since they spent all that time coding, there was a lot of changes. And so now they have to debug that failure. Feeling victorious that they found the failure, they go to lunch, declutter their mind from that failure, reassess, feel better about themselves. They come back reinvigorated and they code a little bit more. Okay, they're doing good. They send it to build. They're anticipating that build, waiting for it to run. It worked. Okay, awesome. So then they send it to CI and they see what happens in CI. Also on anticipation, seeing if anything happens. They don't get the results of that CI. They're waiting on pins and needles, but they have to go participate in the sprint. So they participate in the sprint. They come back and they see that there were some problems in CI. So they start to investigate what those problems are. More than likely, at least in my case, it seems like it's a flaky test. So you have to go back and fix that flaky test. And then, lo and behold, that's the day. And you're done. You go to bed feeling like you just spent all day kind of waiting for your builds and fixing it rather than actually coding. And you start again tomorrow. Now, I would like to say that this is just, me and my bad coding skills or something. But when I talk to a lot of colleagues, this is something that they've had too. And at Gradle, this is something that everyone sees and experiences, and we're very upfront with it. And so we wanted to do something to fix it. And here's a little bit more data to kind of hone the point that this type of schedule is a pretty normal thing. Namely, this is the shortage of software engineering jobs that we had in 2019. Now, I chose 2019 because that's before, everything happened. And so even before, the pandemic started and everything, we had almost 1 million software engineering job shortages just in the United States. And maybe we're starting to churn out more software engineers now, but people started going into school a lot and online schooling. And so if you look at the total annual STEM jobs through 2022 versus recent college grads, you'll see a pretty surprising thing. The blue line here is the total number of job openings, and the orange line is how many bachelor's degrees we've actually given. And so you see that for computing, which is just the big broad blanket of things that go into software engineering, we have a huge discrepancy between the total number of job openings and the total number of bachelor's degrees awarded. Now, there's a lot of caveats in this. You don't need a bachelor's degree to go into computer coding. Okay, that's fair. But in a lot of the other fields, you can see in engineering, there is more bachelor's degree than there's actual positions. In physical science, a lot more bachelor's degrees than jobs. And in life science, it's really sad how many bachelor's degrees were offered compared to the total jobs. And the same is true for the pure math degree. And this is one of the reasons why, like my degree, my original first degree was actually in physical sciences. And I wanted to be, an astrophysicist and work that, but I was good at coding. And so even though my bachelor's was in physical science, the jobs were in computing. And so I took my bachelor's and I migrated to the computing jobs. And this is something that's also very true for the math profession. My good colleague, they have their degree in mathematics, applied mathematics, and they shifted it to computing because that's where the jobs are. And there's a lot of openings in the computer science industry, but the other problem is that there's a really high turnover, which means this is a compounding effect. The graph on the right, you can see that these are the sectors with the highest turnover rate. So that means people coming into and then leaving that sector. And technology software, it was, according to this one, and if you have the slides, there's a link there. software technology is the highest turnover rate. It's even higher than retail and consumer products. And yeah, I worked in retail and consumer products when I was a teenager. It wasn't fun, but I think I didn't like it nearly as much as I like technology. That's why I'm here now, right? So it's kind of hard to think that there's so much turnover in technology. So this is something that we need to fix. We need to fix at a fundamental level so that we can drive those innovations and essentially solve all of the world's problems. So let's think about some of the problems that we face in our engineering organizations and our computer science organizations. Oftentimes, people view it as a very solo field, and there's this inefficient collaboration in engineering when they're investigating a problem. There's some things to fix this now. For example, there's a lot of people that like pair programming and some people that really like mob programming. I'm a big fan of mob programming. I just had a session yesterday where it was three of us getting together and scratching our heads on some problems. And only by having everyone kind of work together do you feel like you can move forward because the problems are so hard. But it also allows you to really start bonding with people. Another problem is the slow feedback cycles for developers when making changes to the code base. And this happens when you have your project and you know it's going to take 15 minutes to build down the line. And so instead of shipping it often, you instead do a whole bunch of changes locally, like, oh, I know these changes will work. I know these changes will work. And then when you ship it, it takes so long and starts breaking that you ended up making too much change. And so people don't want this slow feedback cycle. We need a faster feedback cycle. There's also a lack of knowledge on how software is built in the organization. These days, we're working on projects that are almost millions of lines of code. We had a change in our last release, and it was something like 50,000 files had changed. And that's just from one release to another. And that's too much for one person to actually understand all of those changes. And in order to increase the knowledge inside the teams, we have to collaborate more, but there's also other tools to help. There's also a high CI infrastructure cost. How are you doing this continuous integration? And there's unreliable local development. So does that local setup match somebody else's? These are all the problems that we're having. And ultimately, there's a huge competitive disadvantage by shipping features slower than needed and with lower quality than expected. That's because if it takes too long to ship the product, that adds to the time it takes for the MVP or for the next release, and that costs money. Not only does it cost money, but it reduces the developer satisfaction and motivation. And then, going back to a few slides before, if you have a more unhappy developer, one with less joy, then they're not going to be as motivated and they're not going to be as creative or as innovative. Now, problems with software aren't a new thing. And, computers are, even if you go back 100 years, not a new thing. So there's been some developments in software over time. In the 1970s, the software industry had chip manufacturing. In the 1980s, we had business process reengineering. And in the 1990s, this is when I start to actually know what's going on and understand things. We had change management. And then what a lot of people still use today in the 2000s was Agile, Lean Six Sigma. 2010, and this hasn't gone everywhere. We had DevOps. That was a really big movement, and you'll still see a lot of DevOps everywhere. And so we still have this frustration with software. So the next big thing that people are starting to embrace is the developer productivity engineering. Now, why hasn't DevOps actually fixed this problem? Well, DPE is out of scope for DevOps. DevOps focuses on the delivery of the product rather than the actual developer experience. DevOps is kind of the nitty-gritty technology for the product, whereas DPE is how is the developer feeling, and it's concentrating on kind of the joy of developers. Now, this is something that hopefully makes sense to you because a lot of companies have gone into a more humanistic approach. And this is essentially the humanistic approach to software engineering. So we are introducing developer productivity engineering. And this might be a new term for you, even though it's been there for a few years. But DPE, it takes an engineering approach to productivity. So it uses acceleration and analytics technology to improve the developer experience. And this overall aligns with a lot of the management goals: faster time to market, a reduced cost, and an improved quality. So for the compile go task, the inputs are the source file, the class path, the Java version, compiler configuration, and the outputs are the compiled classes. And so for the test goal/task, the inputs are the test sources, the test runtime classes, and the outputs are the test reports. So we also have caching that goes in, and all of this is kind of the things that go into what makes the developer a happier person so that you can have a faster time to market. Now, there's some companies that have already adopted DPE, and so when you do a survey with those companies, we found that DPE fosters this developer joy. 81% of surveyed IT professionals would agree that DPE's impact on their toolchain makes their job more enjoyable. And so there's the source for that if you want. But this means that, 4 and 5 know that having DPE means that their job is more enjoyable. So the turnover is going to go down. As people are more happy in the fields and feel more successful in collaboration, then you're going to start to see more people come to computer science as well. So that was all the background. Now that you know the why you should have DPE, you need to know the how to implement it. And so that's going to be kind of the focus next. So here is a pretty normal situation. We have a lot of friction and slowdowns in the developer experience that are caused by unreliable and or slow build infrastructure, which these often represent a black hole in productivity and are not in scope for the traditional DevOps people. So let's talk about the benefits of DPE. First, the faster feedback cycles through this build and test acceleration technologies. This means there is less wasted dev and idle time, less wait time, which leads to less content switching and more focused developer because they can stay in that creative flow. All of this contributes to a step function increase in productivity because builds are fast, developers more often develop, and this leads to the number of effects that they can see in a higher quality code. So how many times is it that you're coding away, you're doing something, you're having a good time, and then you ship it to building, and you don't want to leave that creative flow. But that build takes 15 minutes. You can't sit there and watch that build. So you know it's going to take 15 minutes. So you go and start either coding something else or catching up on your collaboration like Slack or email. And then you have to context switch to that. Coming back into coding takes a lot of mental effort. And this context switching can be very abrasive. So if a problem takes too long to compile, then that means more context switching, and that's generally a bad thing. The next major benefit is inefficient troubleshooting tied to the BuildScan analytics tool, which facilitates the root cause of the failure. So what I mean by this is oftentimes if you know it's going to take 15 minutes to compile your code, you're going to want to have this huge, massive thing that you ship away because it's going to take 15 minutes or more no matter how much you send. And so you send it as less often as you possibly can. So when you get that failure coming back, then, well, you don't know exactly where it is. If you made a change to 100 lines, it's any one of those 100 lines. So you now spend a lot longer to fix that problem. So this person they're doing a local development and they send their code, it comes back, the code takes too long to fix. They send their code, it takes too long to compile. This is the cycle that they have. Now, this developer, they generally work 240 days a year. And then if you're at a company that has hundreds of developers, this leads to a really high cost and a reduction in productivity. Definitely not something we want. So, needs to be fixed. So let's look at the pillars of DPE and how we can start to see what your problems are and go. So here are the pain points that a lot of developers have had. Pain point is idle/wait time. They're waiting for their build to actually run. Inefficient troubleshooting. They sent that code and they know it's one of 100 lines, but they're not sure which one it is. Flaky tests and other avoidable failures. Something fails because of the wrong version or the wrong environment. Who knows why? No metrics, KPI observability. And so how do you know when it's successful or not? And then inefficient use of CI resources. So these are kind of the pain points that we noticed. And so they're the pillars that we have established to kind of help and what we call the DPE. So let's look at the first one, the idle/wait time. So with this idle/wait time, one of the ways to solve it is going to be faster feedback cycles. And so when you ship that code, you don't want to wait 15 minutes. You want to wait ideally 1 second and then get it coming back. So there's a lot of ways to kind of fix that faster feedback cycle. One of the best ways is to use build cache, and if you're doing testing, test distribution. Build cache is just so amazing, especially if you use build cache in remote environments. Oh, it can save you so much time and is just one of the best things ever. Even if you have just your CI doing build caching, it's phenomenal. And so what I mean by build caching is every time you build your software, you cache it. And so if you make a change, then maybe that entire change is cached. And so it just pulls from cache and you don't actually have to wait it off from your build. If you're using build cache, maybe somebody else has already done that change and you could just pull that build cache from the cloud. And again, all that's costing you is the network time. So that means when you ship your code, it just pulls from cache and you see the result nearly instantly. A lot of times we're making very similar changes if we're going really fast with the feedback cycle. We're changing one little thing in a private method. We don't have to wait for everything else to compile and run. If you're making one little change in some private method, then a lot of the other things can be pulled from the cache, and just that little private method has to be recompiled. So build cache can save that. And so if you're noticing that you have this huge wait time, how can you cache the results of your build so that you don't have to waste time? And the other thing is test distribution. There are so many times we've seen that the tests go in a serial manner. You do this test, and then this test, and then this test. But if you're made just one change on one little private method, do you even need to do all of those tests? And so it's really important that you break up your tests and also kind of run your test a little bit more in parallel. Distribute the test as much as you can. Now, the details of this look very differently for every scenario, but we've noticed that having that fast feedback cycle is one of the most important things for having that happy developer. So let's look at kind of what we determined are the effects of this fast feedback cycle. So this is a little bit noisy of a plot, so it's going to take a little bit to get through. The key down at the bottom got cut off a little bit, but the blue with a lot of shapes is the new behavior, and then the green with kind of small shapes is the effect. And so we have these faster feedback cycles, and right off the bat, the faster feedback cycles means that the developer is going to have less idle wait time. They send their build and they see that it comes back really quickly. And so when they see it comes back really quickly, they're either waiting less or they don't have to context switch as much. And well, if you have less context switching, then you're going to have a more focused developer. More focused developer leads to a higher quality of code and a higher productivity. And that productivity is really important as well. But if there's less idle wait time, then they're also going to start to change their behavior. Their new behavior is they're going to build more often. If they know they don't have to wait as much, then they're going to ship their code more often. Oh, what if I add, this test right here? I'm going to ship it. And then they get it to work or not work. And then, oh, what if I add this variable name and initialize it here? They ship it. They're going to see it shipped more often. And when they ship it, they're going to see a lot smaller change sets. Now, having these smaller change sets where you really only have a change of like 1 to 5 lines of code means they're going to have a lot more efficient troubleshooting. If there is an error, they're going to be able to see exactly where the error is. They don't have to go and hunt and peck through 100 lines of code. They know it's going to be in one of those 5 lines that they've changed. But another thing that I absolutely love is that there's fewer merge conflicts. I don't know how many times I've sent my code to GitHub or some other version management system, and I see that there's just a whole bunch of conflicts. In some cases, there's been so many merge conflicts that I've had with my code that I've just given up that entire branch altogether and started from scratch. And, well, that wasted my time completely, right? So overall, it's going to be a faster mean time to return, and then you get a higher quality and higher productivity. And so faster feedback cycles essentially lead directly to a higher quality and a higher productivity. And this is something that you want. So let's see how this affects kind of a larger scale of people. So let's say we have 2 teams. Team 1 has 11 developers on it. Team 2 has 6. The build time on T1 isn't too bad. It's just 4 minutes. 4 minutes is not enough to go and context switch. 4 minutes isn't enough probably to get up and go make yourself a cup of tea. But it is enough to kind of sit there and wait for them to see the code. Team 2, the build time is 1 minute. And so with it just being 1 minute, yeah, they too, like the team 1, are probably sitting there waiting for their code to run, but it's only 1 minute. And so, maybe they stretch real quick, ponder how well their code is going to go. Oh, it's been a minute, and they come back. So the result of this is that team 2 is going to build more often. The faster the feedback is, the more often the developer will ask for that feedback. The more often they ask for feedback, the more they can fine-tune their work, which that goes to the higher quality of work. The slower builds mean there's less developer context switching. Oh, I know this is going to be 4 minutes. Maybe I should just go on to Slack and see how everyone's doing. The aggregated cost of waiting is actually surprisingly high. That 4 minutes built up over 850 builds for 11 devs, that's a lot. So even moderate improvements are worthwhile when we push them at scale to reduce the idle wait times. Now, just going back so you haven't forgotten this, we have all of these developers and they're context switching between coding and maybe going to Slack, maybe they're checking their Twitter in those 4 minutes. Who knows what they're doing in those 4 minutes? But that context switching is amazingly costly because remember, whenever developers are coding, they're using their brain at a really high level. And I don't just mean they're using one part of their brain. Whenever they're coding, whether it's reading coding or writing coding, they're actually using both areas of their brain because writing code is kind of like solving a logic puzzle, but it's also speaking kind of like another language. I oftentimes make the joke that I'm not even fluent in English, as some of you probably make fun of me for not pronouncing words right or anything. But I am pretty fluent in Java. So, by the way, I'm not fluent in any other languages, just Java. English, Spanish, nothing, just Java. So, whenever we're writing code, it's essentially tying into part of that language sector. Not the full thing is the language sector, just part of that language sector. And the same with the logic and puzzle. So when people are writing code, they're using both halves of their brain. And then if their build takes time, they have to context switch, which means a different part of their brain is activated and that coding part is deactivated. So there is actual effort in doing that context switching. So now let's look at what it looks like. Oh, I clicked on the link accidentally. Sorry about that. That's what happens with the whole image as a link, huh? Okay. So now let's look at it when builds are faster than 10 minutes and how they cause that significant waiting time. So the slower build means developers are doing that context switching while builds and tests are finishing. So like I said, this cost is really high, even for fast cycles. So we need to have even that moderate improvement. So again, let's look at another scenario. And the reason why I have these scenarios with, 11 developers and whatnot is because these are real cases. And these are people that have taken their developer team and they've actually utilized DPE practices to see how things change. So in this case, we have 6 developers versus 100 developers. And the local builds per week for these 6 developers were over 1,000. For the 100 developers, the local build was 12,000. Now, this is 100 developers versus 6. It's crazy to think of those numbers, right? Because that means that 100 developers are not nearly as pushing as locally as those 6. And that's because the build time for those 6 developers is 1 minute, whereas those 100 developers have a build time of 9 minutes. That's huge. That means you're sitting around and waiting and waiting and waiting. And, like we said, even moderate improvements are worthwhile. The 6 developers with a 1 minute build time, when they applied DPE, they got their build down to 0.6 minutes. The 9 minute build time went down to 5 minutes, so about half of an improvement. So overall, with 6 developers just dropping it by 40%, that increased their production by about 44 days in a year. For that 100 devs, that increased their days by 5,200 days. So you can think about it as by changing that build time, we've actually made it so that we essentially have more developers on that team because those developers are a lot more productive. So this is how you can take your normal developer and make them a 10x developer. Or if you have that 10x developer, then you could take them and, make them a 100x developer or something. It's just a matter of, if they're wasting their time by waiting for their builds, then this makes it so they don't have to wait anymore, and you're essentially making them a lot more productive. So going back to the other idea we had, and that's build cache. Build caching delivers a fast build and test feedback cycles. So if you can cache your things, do it whenever you can. It's really important that you don't have to reproduce everything all the time. There's the normal saying that, you shouldn't have to make the wheel. Well, that's true with your developers as well. If you have a really easy test, they shouldn't have to make that test every single time. Test distribution can also make tests even faster. If you take your tests and you start to distribute them out and run them in a more parallel fashion, then you're going to also see a huge increase in your developer productivity and your developer joy. So all of that was the first pain point that we had, that idle wait time. So that's just the first one. The next one is inefficient troubleshooting. And if you have inefficient troubleshooting, then you're not going to want to do it very often. So you need to have, of course, faster troubleshooting. So how do you get faster troubleshooting? Well, you can look at your build and scan it for the root cause of the problem. And that's something that, who is looking at your overall builds? And how do you get to the root cause of that problem? When you have 100 lines, it's going to be tough to see which one. So they kind of go in line with each other. Now, next, there was a quote that I heard that I absolutely loved, and that is flaky tests, the pit of infinite sorrow. Now, I don't know how many times I have done something and sent it to build and it failed. So I come back and lo and behold, I can't find a problem. There's nothing wrong with it. Everything looks perfect. So I ship it again. I wait my 9 minutes for my build. There's no problem. It was the same exact thing, but just a different build. I have no idea what happened. This is what we call the flaky test. And yes, the flaky test really is the pit of my infinite sorrow. So please, please, for the sake of all developers, get rid of flaky test as much as you can. Have a flaky fix-it day, whatever you can, get rid of flaky test. But let's verge back into the other idea of testing. Here's another quote that I like. Speed is the new currency of business. And this was the CEO of Salesforce for a while. And so we want to make sure that things run as fast as possible. And one of the ways to do this is through test distribution. And this is when you execute multiple tests in parallel rather than waiting for one to run. And you can distribute the test horizontally across a pool of agents. And at scale, this can speed it up a lot. And the good thing about this is tests can be ran more than once. And if you can run tests more than once, then you can start to see which tests are flaky. You can see that this test fails half the time. This test fails 1 in 10 times. And you can start to see that this is a flaky test, and so we need to get rid of this test. And then you can start to see, oh, this test is a reliable test, so we need to keep it. And so by having test distribution, that's one way for you to start to get rid of your flaky tests. Okay, so that kind of summarizes how to clear up flaky tests and other potentially unavoidable avoidable failures by having some sort of failure analytics. As you send the test, how are you monitoring it so that you know which is failing more often, and which ones are the ones that are kind of the reliable tests that you should have. And of course, if you have a flaky test, then the next issue is how do you fix that flaky test? So that leads to another one. And this is kind of one of the fundamental questions and a huge area that people are exploring right now. You can observe a lot just by watching. Yes, of course. Everyone knows who this is, and of course, I'm probably exploiting this quote far and beyond what its use case is for. But you can observe a lot just by watching. And so, if you're in a team of developers, the question is, what are you watching? You send these builds, you have these testings, you have these maybe flaky testings, but are you watching that, or is it just the individual developer that sends it, that gets it back, that has that longer feedback cycle, that is experiencing the problem? So it's important that you start to establish some trends and insights to your workflow. Who is watching the build times? Do you know which tests can be run in parallel? Is there someone in charge of this, or is it just the responsibility for every developer? If it's the responsibility of every developer, then odds are no one is doing it. Um, so another quote that I like is, how does a project get to be a year late? One day at a time. It might seem like you fell behind today, you didn't get quite everything on your to-do list done, but over the course of, a year, those little things pile up. And so if you don't have people watching your build times or which tests can run, if you're just having, your developers at it here and there, then you're going to get behind. So it's really important that you have somebody that takes ownership of this. And as they take ownership of this, they start to make changes to kind of the process for how things are built and cached and tested. A really good book that I highly recommend you read, and I'm not affiliated with these people at all, but it's one of the better books out there, is Observability Engineering. And this book was published, oh geez, probably within the last 6 months or so, I'm guessing. And it is just awesome to see how by watching things, you can see how things work and then make changes for the better. And so if you haven't seen this book, definitely check it out. It's worthwhile because observability leads to solving problems. Okay, so and that leads to the last two pain points we have, which if you don't have the metrics or that KPI observability, then you're not going to know necessarily when things are wrong. And so one of the ways to fix that is to have that continuous learning and continuous improvement on your team. One of the things that I like is, you have flaky fix-it days, you have performance week. That's something that we have where, all week a team will just drop everything they have and they'll focus on performance. And that's really awesome because that means we see performance improvements normally those weeks. So one of the ways to fix that observability is by having trends and insights. You take your metric and you put it somewhere so that everyone can see in a public area for your team, and then you base your insights off of that. And then, of course, you have to have a pain point, inefficient use of CI resources. How are you distributing them? If you have CI resources, is something just sitting there while another test is running? And so you want to make sure that you cache as much as you possibly can. Now, just because you've done this once doesn't mean you're done by any means, right? Because without a focus, problems can sneak right back in. You have something that looks like a really good infrastructure change, and that's great, but that can cause problems in the end. Maybe you have new annotation processors or new versions, rather than using Java 18, you're switching to Java 19, or, rather than using TensorFlow version X, you use the new X. Having those version changes can influence, the overall time to the end result. And then you have a higher feedback cycle, which is what you want to avoid. You can have your build logic configuration settings change. Maybe you're pulling in more plugins or something like that. Maybe you refactored your coding. It's kind of sad, but we've actually seen that just by refactoring something can impact the build speed. I know that sounds crazy. I don't understand it. If you've seen that, then please let me know in the chat while I'm here that you've seen this too, so I know I'm not crazy. Don't know how it works. Maybe your new office locations will cause problems to sneak back in. We were using some cloud-based environment for our testing, and we noticed that all of our tests were like 20% slower. What did this 20% come from? What happened? Well, we were brainstorming, and the cloud server was starting to get dusty. And because they're not actually up in the cloud, they're a real place. So the cloud server was starting to get dusty and the heat was starting to build, and that was causing our times to slow down. Um, and this is something that, if we didn't have those trends and insight, we would have never have seen. But it was kind of cool that we could be like, yo, your server's running slower. And they, cleaned it off and fixed it or moved us to a new one. Who knows? But by having new office locations, even as your environment goes to a new cloud server, things can change, right? And without observing it, it's impossible to notice it and get that faster development experience. So hopefully I've convinced you that this is an important thing, and hopefully you see kind of how to have developer productivity engineering inside your business. But with time, this DPE will become a standard practice because, developing is awesome, and the world should foster this developer joy. Build happiness was one of our slogans for a while because we want people who build, especially, to be happy. We see that the turnover rate in software is really high, and we want to fix that. And, people are trying to hire more software engineers like crazy. I think we have something like 40 job openings on our site right now. So if you happen to want to have a joyful developer experience where we do DPE, come check out our career page. But this DPE is something that other institutions are starting to do as well. Here is a recent pull from the job search that I found. And you can see that we have Spotify is how we improve developer productivity from our DevOps team. So their DevOps team has now taken to heart the idea of, DPE and so ingrained into their DevOps that it's kind of the next thing. We have careers, Netflix, senior full stack software engineer for developer productivity. So they have an entire, team of people that's focused on developer productivity. We have Twitter. Their career role is senior software engineer developer productivity. So that's at Twitter. The bottom left you can see is a LinkedIn careers, and my head's in the way, but that says productivity and IT. We have Elastic is hiring a cloud tech lead for engineering productivity, and SoundCloud hiring a back-end engineer, engineering productivity. And so hopefully you can see that these huge companies, they're hiring an entire person that takes developer productivity engineering and starts to build the ideas behind it to essentially lay the groundwork moving forward. Now, not all teams are as big as, Netflix and Twitter and Elastic and LinkedIn. Those are huge ones. And so if you need kind of some building blocks for DPE and just kind of where to get started, we have a free wrong way. We have a free ebook for you, Developer Productivity Engineering. You should be able to scan that with your phone, even this recording, and then it pops up. And it's a really great book that essentially talks about what I just said about how do you foster this joy in developer productivity engineering. And then, maybe you won't have a full-scale job about this, but you'll start to ask the questions. Who is watching our testing? Who is watching our caching? And so that you can lead forward to making everyone in your team happier and more productive. Okay. And like I said, this is a recorded talk, and so I'm in chat if you want to chat me. My email is up there, of course, and my Twitter has been up there. So if you want to chat, reach out to me afterwards, but I'm also here talking to you in real time, which is kind of cool. I hate the sound of my own voice, and so I probably don't watch my own presentation, or maybe I'll watch it and just not listen to it. So I definitely will be in the chat. And of course, I want to thank the DPS Summit people for having me give this talk. And that is all. I'll see you in chat.